For this clip, we're gonna talk about section 6.4 and 6.5 in the book. It's about functions of two continuous random variables. Previously, we have talked about discrete random variables. Now it's gonna be continuous random variable. So this is from the first example. We're gonna look at example 6.9 from the book. So let's X and Y have this joy PDF. Okay. So it's the small case of f, right? The PDF is equal to 1 over 15, right? So it's a constant when x is between 0 and 5 and when y is between 0 and 3. If x and y is outside those intervals, then the PDF is equal to 0. Okay? So with this in mind, we can find the area where the PDF is non-zero. So if I draw this two-dimensional plot with x on the horizontal axis and y on the vertical axis, so x from 0 to 5 is right here. Y is from 0 to 3 is right here. So that means within this rectangle, the joy PDF is equal to 1 over 15. Anything outside, it's going to be 0. Okay. Now let's define the functions w. Right? So w is the maximum of x or y. Okay, so uh, we generate x, we generate y, and we compare its value. The maximum of the two value is equal to w. Okay, and it say find the PDF of this random variable. Of course, w is also random variable because it's a function of two random variable. Now, how do you find the PDF? Well, the first thing is we're gonna find the CDF. Once we get the CDF, we can differentiate and we can obtain the PDF. The CDF is denoted by this capital letter F. Is the probability that the random variable w is less than or equal to some number w. So this small case w, this signify or denote just some number. Okay. The big case w, this is the random variable. Okay. Now we know the random variable w is a function or the maximum of the two random variable x and y. Okay, we want this to be less than w. So let's take a look at some number. For example, if we let this small case w to be 2, right? So we want to find the probability that the maximum between x, random variable x and y is less than or equal to 2. If the maximum of the two is less than 2, that means if you look at the x, well, x has to generate some number that is less than or equal to 2. And y is also has to be less than and equal to 2. This is the case because we say that the maximum has of the two has to be less than 2. That means either one of this the two cases here must be true, right? X has to be less than or equal to 2 and y has to be less than and equal to 2. Now, how do we find this probability? Basically, we want to use the joy PDF. So remember, the joy PDF looks like this orange rectangle. Anything outside is going to be 0. So if you look at this event where x is less than 2 and y is less than 2. So x equal to 2 is right here. Y is equal to 2 is right here. So we got this 0.22. X and y less than 2. That means it's corresponding to this red area. Okay. So we want to find the probability of this red area. But remember, the PDF only define or is non-zero only in this small orange rectangle. So basically, we're gonna integrate just this overlapping area between the red and the orange. Okay. So we want to find the integral of the joy PDF, right, of this overlapping area. So x between 0 and 2 and y is between 0 and 2. Okay, so this is the area of integration for us. The joy PDF is equal to 1 over 15, right? It's a number, it's a constant. You can take it out from the integral. So you integrate x from 0 to 2, right? You get 2. Integrate y from 0 to 2, you get another 2. So the probability is equal to 4 over 15. It has to be less than 1. Okay. Now, if you think about this, right? Here is W is equal to 2. If W is less than 0, then we are talking about uh, the red region that is, below here. For example, if W is equal to -1, we're looking at this red area. And you see that this red area is not overlapping, right? This orange area. So you integrate something uh, where the joy PDF is equal to 0. So that means for any W that is less than 0, for this example, the probability is equal to 0. Okay. Let's look at another next case. If W is between 0 and 3, right? Actually, we encountered that before, right? So W, so remember we are looking at the event that is represented by this red area, where the corner here is W and W. Okay, so that means the overlapping area is this rectangle or this square. Okay, so if you want to find the probability in this case, again, it's gonna be the integral of the joy PDF, which is a constant. We integrate from 0 to W, right, on the x-axis, and the y-axis from 0 to W as well. Okay, so we got this. And again, this is very straightforward integrations. So 1 over 15 can take it out. You integrate one variable, you get W. The other variable, you get W, so it's W squared. Okay. Now what happened is if W is bigger than 3 but less than 5. Okay. So you have something like this, right? So W is bigger than 3, so that means the area, the red region is going to be something like this. Okay. It's still less than 5, right? So 5 is right here. So you see that the overlapping area is this much. Okay. Okay. Right? So again, we integrating the joy PDF, which is 1 over 15. For the y value, we integrate from 0 to 3, right? Because that's where the joy PDF is non-zero. Okay, 0 to 3. But for the x, we're gonna integrate from 0 to the end, right? W. Okay, because it's still it's still below 5. So 0 to W. Okay, so you integrate this 1 over 15. You can take it out. You get 3 multiplied with W, and you get 1 over 5 W. If W is bigger than 5, that means the red regions where this corner, the coordinate of this corner is W, and W, it's gonna cover the whole orange area, right? So that means we're going to create the joy PDF, which is 1 over 15 from 0 to 5, right, for x, and 0 to 3 for y. Okay, to integrate this, of course, you're going to get 1, right, because this is the entire, cover the entire possibility. Okay, so at the end, we find these different cases of the CDF. If W is less than 0, the CDF is equal to 0. Between 0 and 3, it's W squared over 15. 3, between 3 and 5, it's W over 5, and if it's bigger than 5, then it's 1. If you plot the PDF, right, you get here 0, and then you get W squared over 15. You get W over 5. This is a straight line, and then a constant one, right? So you see the CDF is monotonically increasing. Okay. If you want the PDF, then you differentiate, right? So differentiate 0 or 1, right? It's a constant, you get 0. Differentiate W squared over 15. The power 2 comes down, so you get 2W over 15. And the other case, you differentiate W over 5, you get 1 over 5. Okay? And 0 everywhere else. If you plot the PDF, see that here's 0. And between 0 and 3, you get this 2 multiplied with W over 15. Okay? From 3 to 5, you get a constant value, which is 1/5 or 0.2. Okay? Okay, so let's look at another example. This is from example 6.11. Again, we have continuous random variable x and y, but the joy PDF is a little bit different. It's equal to 2 when x and y is within these regions, and 0 everywhere else. And we want to find the PDF of a function of random variable. It's w. The function here is very simple. It's x plus y. Okay, you take these two random variables, you add them to get another random variable. You want to find out what is this random variable. Okay, so let's take a look at this joy PDF first. Y between 0 and 1, y is between 0 and 1, that's easy. X between 0 and 1, 0 and 1, that's easy. The last constraint is x plus y less than or equal to 1. Now, if you plot x plus y equal to 1, you get this straight line, right, where the slope is negative 1, right? How do I get this plot? Very simple, right? So maybe you try x equal to 0, then you see that y must equal to 1. So you got this point. You try y equal to 0, then x must equal to 1 to get this point. And you know it's a straight line, so 2 points are enough. You use your ruler to connect these two plots. You want x plus y less than or equal to 1. It's gonna be on this side. How do I know? Well, I just take one point on this side, maybe 0, 0. If you add 0 plus 0, it's definitely less than 1. So we know that it's gonna be on this side. Okay. Now, to find the PDF, again, we're gonna use the same technique. We're gonna find the CDF first. The CDF is the probability that W is less than or equal to some number W. So W here is number, and random variable W is x plus y. Okay, so let's take a look at some number first, so we understand what's going on. For example, let's take 0.5. So we want to find the probability that x plus y is less than or equal to 0.5. Okay, so let's take a look. Remember this orange triangle. This is where the joy PDF is non-zero. So let's see x plus y equal to 0.5, right? Because we are looking at this event, right? X plus y less than or equal to 0.5. But let's find this first. Equal sign. So it's a straight line that's going to this 2 point, right? 0.5 x equal to 0.50 and y equal to 0.5 x equal to 0. Okay, and we want less than, right? So that means it's going to be on this side, right? On the left hand side. On the right hand side, this is when x plus y is bigger than 0.5. We are not interested in that. Okay, so that means the red area, this is where we are interested in. And if we see, we compare this with the orange area, the overlapping area is this red triangle. So we want to integrate the PDF, right, over this red triangle. Okay, so the PDF is a constant equal to 2. We can take it out from this integral. That means all you need to do is you find the area of this red triangle. The area is 1/2 multiplied with the base. The base is 0.5 multiplied with the height. The height is 0.5. You multiply this out, the probability is equal to 0.25. Okay, so we get one number, right? We know that the CDF as 0.5 is equal to 0.25. Now we have some idea, so we're gonna generalize this. So let's say W, the number is between 0 and 1. So that means this straight line x plus y equal to W, it's gonna be within this orange area, right? For example, when x plus y equal to 1, it's exactly here. When x plus y equal to 0, it's gonna be this straight line. Okay, so W is gonna be in between. Okay, again, we're looking at this triangle. Okay, so we integrate over the joy PDF, which is 2. We take it out from the integral, and we're gonna find out area of this triangle, which is 1/2. The base is W, the height is W, so it's W squared. Okay? So that means the CDF when W is between 0 and 1 is equal to W squared. What if when W is bigger than 1, right? We try number that is bigger than 1. So that means the area, the red area that we are interested in, it's going to move rightward, right? And the area will cover the entire orange triangle. So that means if you integrate this, it's going to integrate over all the PDF, the joy PDF. So that's probability is equal to 1. Okay. What about if W is less than 0? Then you see that this straight line move downward. And the area where x plus y is less than W is going to be on the left. So there's no overlapping between this red area and this yellow area. So that means we integrate over nothing, right? It's integrate over 0. So the probability is equal to 0. So I think we cover all the cases, right? So the CDF for this random variable W can be broken down into 3 cases. When W is between 0 and 1, then it's W squared. Bigger than 1, then it's 1. Less than 0, then it's equal to 0. You can plot this, right? So the CDF looks like this, and again, keep increasing from left to right. Okay. The PDF, you can just differentiate, right? You differentiate a constant, you get 0. You differentiate W squared, you get 2W. Okay. And the CDF can be plotted like this. Between 0 and 1, it's 2W, right? So it's a straight line going up like this. Anywhere else, the PDF is equal to 0.